So let's move now to chemical reactions. You're ready for that because you already know how to turn atoms into ions. That's determined by either how many electrons an atom gains or loses to become isoelectric with the noble gases, or how many protons it loses if it's an acid. And you know how to turn ions into molecules. You know how to put them together and make them charge neutral. So what happens when we get a bunch of molecules? Well, sometimes they react. For example, hydrogen can react with oxygen to produce water. So let's look at that equation at a 30,000 foot level. The atoms on the left are called reactants, or sometimes reagents. And this could be shocking, but sometimes the reactant side of the equation is referred to as the left side and the product side as the right side. Let's have a look at the equation presented here. Now, one thing we need to do is balance the chemical equation. Why? Other than you need to answer something like that correctly on a test to get points. Well, the reason is because the law of conservation of mass requires it. Well, what is that law? It basically says however much weight you start out with, because you're not creating or destroying anything, you must end up with the same amount of weight on the other side of the equation. You must end up with the same amount of weight that you start with. In terms of counting atoms, because atoms aren't created or destroyed in a chemical reaction, that means if you have two hydrogens, and let's look here, those are the little white blocks there. So let's say we have two white blocks and we have one oxygen molecule, that's red, and we have two red blocks. What must we wind up with at the end of the equation? We must end up with two whites and two reds. It's a chemical reaction. They can recombine in any way they want, but you've got to have two white ones and two red ones. Well, let's see what we have. We have two H's and we have two O's on this side of the equation. And what do we have on the other side of the equation? Two H's and one O. Oh, what happened to the second oxygen? It just disappeared. But you can't do that. What that means is the equation is not balanced. You have violated the law of conservation of mass. So what do we need to do? We need to balance the chemical equation. Why? So that the law of conservation of mass is obeyed. So now that you know why, let's see what we would need to do to that. Oh, I know. We put a 2 in front of that and a 2 in front of that. Well, what do we have now? We have four H's. Let's draw an H2 and an H2, and we have one O2 molecule. And what does that go to? Two H2Os. We have an H, an O, and an H, and an H, an O, and an H. And here you can see four hydrogens, and a total of four hydrogens, and two oxygens, and a total of two oxygens on the product side. The equation is balanced. If you want to look at that graphically, you can see that there's one H2O, and here's the second H2O. So basically, here's all a chemical reaction is. You just break the original structures into individual Lego blocks, and then you recombine the Lego blocks to make something different. That's all there is to a chemical reaction. But you have to remember, you must end up with the same number of Lego blocks with the same number of atoms as you started with in a chemical reaction. Now the question becomes, how did you know how to balance the chemical equation? How did you know a 2 went before the H2 and a 2 went before the water and you left the oxygen alone? Well, that's a somewhat complicated question, and we'll save that for the next video.